Hello, chat. How you doing? I need to turn on my captions. My dropping frames. My stream preview is paused. Um. Okay, it's funny now. Open my chats. Okay. Now we just need to go through and should be good. Check this chat really quick. Okay. Sorry, I'm chatting with someone on VGen. There's a project which will probably be pretty difficult. And he is inquiring upon. I don't know how likely it is to work, so I'm unsure of if I can make that many event subscriptions. Wait. We might just be able to use Helix, actually. Okay. Let's get down to brass tacks. I might be dumb as shit. We could have just used Helix. I'm over here trying to use event sub. Not a good idea. I mean, Helix is less. It's not as quick because event sub tells me the millisecond they're live, but Helix I could probably pull every 5 minutes or something. Apparently, I'm allowed to make 800 requests to get streams per minute. But I'm not going to do that because sending a request to query 100 streams or so for every second is going to be. I don't think Dan Clancy's going to like that very much. So we'll probably do like maybe once every 30 seconds. Okay. Where is OBS? Here is OBS. Today we're going to do something very different than yesterday. So as to say that I'm not using the scary display capture. I'm just too lazy to do it. That's all. Is the stream even... Is Mona server running? I think so. Yep. Is Mona server open source? Hold on. I might make my own RTMP server. It is open source. It's GPL though. My main reason of wanting to make my own RTMP server is that Mona server was last updated 10 years ago. So it's pretty old. It also crashes periodically. So I would like to make one that is a little bit more stable. I could probably ask Elmay, honestly. Elmay has an RTMP server. Actually, we could do. I think I have a zip of the source, but it's like a year old. So if he does, maybe I'll template it from that. And if not, then that's fine. All right. First order of business today is we need to update the decompressor, which is not equipped to handle the new file format. The SNRC header has expanded quite a bit. From, I believe, like... Oh, I have the music drive-in. How much was it before? I want to say it was only like 16 bytes, and now it's like 48. I think it was... No, it was 24 bytes, I think. It was SNRC header version file type. And maybe header length, so maybe 28. It wasn't very many bytes, is the thing. Is this the portable apps drive? I don't remember which drive it is. I have so many random fucking drives on my desk. And before I give myself a virus. Oh, it's on his GitHub. Okay. Just type in the address. It's apparently not his, not his GitHub. I actually don't know what his GitHub is. Oh yeah, it's Win10OS. What is Opera GX Nitro? All right, let's plug this in. Stream relay JS. Disgusting. Here it is. Why is this one not visible? It doesn't have a license. Looks like it is built off of a different project. I might template from that. Done an implementation of RTMP live streaming server. And this one's a lot more recent than Mona server. Does seem to be abandoned though. It hasn't been updated in 7 months. Does seem to just kind of work. So that's kind of cool. I'm gonna bookmark this, and we'll come back to it later. I do just want to like use a better server than Mona server, because Mona server is pretty fast. I don't have any major issues with its quality. It's just really old and kind of barely works. Okay. So I want to quickly go through and clean up the compressor just a little bit. we'll call this a dictionary because there is a lookup for it that is this lookup. It's not read-only. Actually, it could be read-only if I gave IFMC Decompressor a constructor. I need an empty constructor. So we can set this as a read-only dictionary lookup. And now we I was wondering where that was. In prepass, we set the lookup because prepass is our major kind of setup phase, but I'm going to do it in the constructor now. So now we can call this a read-only lookup. We can make this read-only as well as this read-only because they are not assigned, they are added to. Except for here, apparently. We could just do .clear. That's fine. Yes, vals is... It actually must not be read-only because we don't know how many blend shapes there are. I'm not assuming that there's only going to be 54 or 52, however many there are. We can make this read-only as well. I want to make this two fields private read-only. Move these up here. Put these in the constructor. We don't need to do this. We can actually do this in reset. We cannot get an invalid byte with the correct IFMC data. So it's okay that we're not using byte parse. This is a performance thing. It makes it less maintainable, but it really isn't that big of a deal. Actually, we can do this can be private read only. Packets are 938 bytes. Okay. So there are 52 air kit blend shapes. Okay, so it looks like it's been 52 blend shapes since just after release with iOS 11. So it's likely to stay at 52. After all, we're not getting more ways to move our face. That in the folded data is a static 48 bytes. Actually, is that even correct? Hold on. 52 times 8 divided by 7. No. 52 times 7 divided by 8 is 46. Have I been writing too many bytes? If I set folded data to be 46 bytes, did it still work? I just discovered a free 1% space saving. Folded data should have been 46 bytes, not 48. I might be a little fucking stupid. The only problem is that now the bit stream of the file does not match. The files are smaller, but are no longer compatible with the previous file format. That being said, because this is pre-release software, I'm going to use the reduced version anyway. Weirdly enough, only on release. Hold on. Maybe it isn't right. Maybe I forgot. I think I forgot to move the objects. Hold on. So output data is 46. It is 48. What? Data bits is... Input data is 54 bytes. Oh, there are two parameters that are not blend shapes that are sent. There's tracking status and some other fucking thing. I think it's lost tracking. No, that's tracking status. So there is extra data. Let's see. I wish I could view this as a string. So there's tracking status. There's one more. I think happy is probably not a standard blend shape. So there are 2 extra blend shapes, which is why it's 48 and not 46. It's because there's 54 fields. So 54 times 7 divided by 8 is 47.25. I mean, technically, we could go crazy with it. Hear me out. So happy is, I believe, a flag and not a blend shape. Same with tracking status. It's a flag and not a blend shape. So it has a value of 0 or 1, which could be represented with 1 bit, which saves us 12 bits from our blend shapes. So we have 52 times 7 plus 2 divided by 8 is 45. So we can actually save those 2 bytes by packing these as single bit flags. Let me look at the iFacial mocap specification. They have changed the format. Wait, they updated it. What? Hmm. Hmm. That's interesting. The example doesn't send tracking status. Hold on. I don't know. Hmm. So I'm looking at also because they made a new one called Face Motion 3D, um, which is like the newer version of iFacial mocap. iFacial mocap is technically deprecated. Um, but Face Motion 3D actually has nearly the exact same interface, except for one thing. The blend shape parameters, despite having a range of 0 to 100 declared, can exit that range, whereas iFacial mocap will not exit that range. So that is a thing. It's actually almost exactly the same interface. The only thing that is different is that they send what appears to be more properties. And they are ampersand separated instead of hyphen separated because they can have negative values. Now, the problem is I don't know what the ranges are on that. Because theoretically, the same compression I use here should work in Face Motion 3D as long as Face Motion 3D has parameters that go between, let's say, negative 127 and 100, or negative 128 and 127. If it's 1 byte, then the compression is still good. I mean, even if it's 2 bytes, the compression's still okay. I just don't know what the range is. And they don't specify. It says that the parameter may contain negative values or the value may exceed 100 despite having a declared range of 0 to 100. But the website's documentation is a little bit shit because it still has hyphen separated parameters declared as one of the things, which is just not true. The other problem is I can't actually parse. I can't use Face Motion 3D data because VBridger doesn't support it. Avignon doesn't support it. So it's like, I don't know. Yeah, it's weird. It doesn't support Face Motion 3D. It shows that iFacial mocap has all of this support, and it just the next one doesn't have any, despite being nearly the exact same thing. I wonder if the password to receive data is the same. Nope. So they got rid of the password. That's basically the number one difference. Probably the actual tracking itself is better, but it is very similar. So it's not free either, which is probably why there's no support. It says it's free download, but it also says they have information about returns, which means that it's not free. Anyway, I don't know if I'll end up supporting it or not. But I do need to change this. We'll change it back to 48 bytes. Because I actually don't have any proof that it is a 1 or 0 status. I mean, I guess I could. I'd have to build a tool to read the entire set of blend shape values and see if it ever changes. Bloodshed values. Blend shape values. I could emit a CSV. It would take some time, but I could emit a CSV. I could emit a CSV. We'll limit a CSV. Okay. We're going to do this, which is going to emit a CSV file, which will have all of every single value for every single blend shape across the entire file written into one comma separated values file that I just realized is never closed. Shit. All right. We are now cooking with comma separated values. While that goes, we can go open the LibreOffice Calc. So I can load in this CSV document. It is one big file. I think I've crashed both Visual Studio and LibreOffice by attempting to copy this in. I don't think LibreOffice will open CSV files directly. Maybe it will. It's going to take a while, though. It's nearly 400 megabytes. That's why it's taking so long. Sorry, there's a maximum sheet row count. Oh. Wild. LibreOffice apparently has a hard cutoff of 100 or 1 million sheets, or 1 million rows per sheet. But now the idea is that we can create a bunch of charts for at least the first. It's about one 3.5 of the file, so about the first 4 hours. We can insert charts. So I want a line chart. Data range will be sheet 1, column A. It's taking a while. I don't think LibreOffice is made for this. I mean, I could use like matplotlib or something. But then I have to do the most disgusting thing of all. That's use Python. But LibreOffice is struggling to make this graph. This Office software that is expecting to have like 200 or 300 labels is not responding well to having 1,048,000 of them. I don't think it's capable of taking an entire column. All right, well, calc is dead. Right. There's two options we have. What I'll probably just do is set a U limit equals 100,000, which will limit the size of the output quite greatly. The U limit did not work. Is it UL? What? The hell is the flag for update limit? That was UL. Let's see. It's supposed to be U limit. Oh, it's also supposed to be U, so unchecked cannot be U. It's ignoring my update limit. Oh, because it declares that U is also a valid thing and U is used for unchecked. We need to change the flag for unchecked. We'll call it NC or no check because U is not a valid. Thing. So now it should do 100,000. Okay. Now we should be able to open that in Calc with a reasonable expectation that it won't crash. I mean, just immediately I can see tracking status is always 0 or 1. What about happy? Happy is always 0. Maybe I'm just never happy. Are there any other ones that might just be flags? No, they all look to be pretty standard. Happy being 0 always is kind of weird. I want to check. I'm going to auto filter it and quickly sort it descending to see if it ever has a value of 1. It does not. It is always 0. Okay. So it could be unsupported or it could be a flag. The problem is I don't have data. I don't know if it's 0 or not, always. Which is where my second trick comes in. Check this out. Where's compressed packet? I always lose myself in this file. It's pretty poorly organized. Okay. I don't know how SNR plugins does not have data. I'll have to close calc to get rid of the lock. All right. So I have it set to break here. And what I want to do is check what is the index of happy. It is 53. So we're going to set a conditional breakpoint here of BS index equals 53. Hold on. Not here. You're going to set a condition here of BS index is 53 and shit is not 0. And now, if we ever have a break here, then we'll know Is it not going at all? Is it really that slow? What's the update number? 243. So this breakpoint is super slow. Here's what we're going to do. If BS index equals 53 and shit is not 0, then break on this line. If we put the condition inside of the actual application, it'll be a lot faster. So this breakpoint is going to let us know if the value ever leaves 0. Okay, so the value was always 0. I wonder if no, because it'd be throwing exceptions. Because the first packet is what we base the entire file off of, so it's always there. I can pack much more efficiently. I can save 2 bytes if I put tracking status and happy happy as the first 2 bits. Which saves about 1% of the file. Is it worth it? Hmm. Problem is, I don't know if I'm gonna check really quick to see if my version of official nocap is up to date. It is. The problem is it's undocumented. So I don't know why these blend shapes are here. And I don't know if they're going to be the same on everybody else's phones. And it's not just the kind of thing where I can ask somebody, hey, can you run this app and it'll get all of this information, because it needs to be in line. So it's not just a simple installation, it does actually disrupt their installation. Damn. But I need data. I mean, I could just add a and add a flag for it. I don't know if the commands check with ordinal or invariant case. If it's invariant, then I have to make it a different thing entirely. It is ordinal ignore case, so it can't be CF with capital F. I might change it to just be ordinal. We're going to change it to ordinal. Hmm. I almost want to do like a compression level. Like C1 through C9. And then different compression levels would give you different values. Or maybe CL equals 1 or CL equals 9 or something. So that you don't have to have 9 different compression levels. Because we can add data to this to be like, oh, compression level data, you know. We could just do that here. Um, We'll set a default to 3 as a application level default. The compression level will be the main way that we change how long it takes and set the output. Because I want it to be like a standard thing. So that compression level is something that you can set application wide. But yes. I don't even need to have this defined because there's no references to it. And with this, I don't need this giant comment. So we want to push 1 byte or 1 bit. So if in data at B is not 0, then output data at out data index, which is 0, or equals 1 shift left 7 no 8 no it's in this byte minus 1. Bits in this byte always decreases. Okay, so this is a fold data which will fold the flag indices. Hmm. Huh? Hold on. The input data length is the number of blend shapes times 8 plus number of blend shape flags times 1. So int n flags equals in data.length minus flag indices.length. Int n blend shapes equals it's this actually. Okay, so data bits equals n blend shapes times 8 plus n flags. This is the total number of bits. I think it's this. Maybe. Let's see. If we have 54 input blend shapes and say none of them are flags, we expect 48 out of this. So we have 54 blend shapes. Bust out the calculator. 54 blend shapes times 7 is 378 plus 0 for flags divided by 8. It does not modulo, it's 2. So it's 8 minus new data bits modulo 8, which is 2. So you get 6, which brings it back up to 48. Okay. Now let's say we have 52 blend shapes. Plus 2 divided by 8. It rounds up to 46 bytes. Okay. So this is correct. Once again, we don't know the order of the blend shapes because they're not defined. It could be anywhere. I'm pretty sure it's always going to be the same because it's the same app sending it, but we're going to assume it's not. So for that reason, we are going to determine the flag indices. I can't specify a length, can I? No. I could slice it. Actually, this is never going to write anything. Hey, wait a minute. This is writing empty values to the file. This is not writing the right span. I think it works anyway, but it wouldn't solve the problem. This would have to be a it's not read only. So we're actually not even going to assign it. And we're going to assign it in the pre-pass. We will assign it in reset just as an emergency so that it's not undefined. But in the pre-pass, we're gonna do packet size needs to be recalculated too. Interesting. If compression level is greater than 4, so it's 5 at least, we compress flags. If bs names.contains happy, we will take int n flags equals 0. This will increase it by 1. I don't remember what the exact text of the other one is, and I probably can't run this anymore. So I might have to look at the header. I don't have the folder open anymore, do I? Okay. The only problem is it's kind of large. Go with Visual Studio Code always. Change default editor to hex editor because it can actually handle opening this large file. Okay, so it's tracking status just as you would expect it to be. Okay. So we want BS vowels to be the same length. So we'll do this detection here. Packet size equals BS vowels length minus n flags times 7 plus n flags. Packet size plus equals 8 minus packet size modulo 8. Packet size divide equals 8. So this should solve the problem of problem. No? It is actually deserializable. Okay. The problem now is we need to make the flags file, or the flags for IFMC handle this new compression method. And we actually need to include information about which blend shapes are considered flags, don't we? Well, I need to run to the bathroom, so I will be right back while I think about the best way to do this. Okay, I am back. I went away to solve one problem and ended up coming up with a bunch of ways to compress the file more, which is not what I left to do. I mean, I didn't leave to go solve the problem. I went to go to the bathroom, but um, I have come up with more complicated ways to compress this file. I have a hypothesis that if tracking status is 0, then all of the blend shapes are the same, and thus we can skip any update that has tracking status set to 0. Which would equal a lot of space saving. The tracking status isn't always 1. So that's something to consider. Oh dear, the file is too large again. And could actually speed up the process too, for things where the tracking isn't being done for a while. One of the problems I'm running into is I want to store the compression level. And because the compression level has 9 values, I can't store it in 3 bits, I have to store it in 4 bits. Right? Yeah. I could make 2 the minimum compression level. 1 will just be treated as 2, which would give me an 8 values to 3 bits. Because I just don't want to burn most of the head or most of the flags. Is the thing. I mean, to be fair, we have a lot of space in the flags field. It's what 64 bits now. I think. Maybe. It's a uint on both sides. Okay, so we have 32 bits for flags. I mean, I guess we don't need to store the compression level in the file. We can actually guess it. Based on the flags that are set. So that's another one I want to do is no tracking run length encoding. So if tracking is set to 0, then the entire update will just be ignored. Yeah, the updates where there's no tracking, it just keeps the same values, although the amount of time it's no tracking is quite low. Let's see. I'm auto-filtering one of the columns to see how often we have no tracking. Okay. LibreOffice Calc refuses to do that. We'll take 200,000 rows. Because this is a pretty decent amount of time. Hello? And congratulations on being first. LibreOffice still can't do an autofilter. Why do you do this to me, LibreOffice? Okay. I might legitimately have to load this into Google Docs. You know what? Fuck it. We're gonna load a 500 megabyte file into Google Docs. Yeah, no, it's been pretty quiet. Oh, nice. Where the fuck is my folder? This one? Nope, it's this one. Let's put this in this folder. It's fine. Here's to hoping Google Docs will allow me to open a CSV with 3.5 million rows. Probably won't. An error occurred while opening this file. Damn, Google doesn't like opening a file with 3.5 million rows. Well, that's no fun. How else am I supposed to do the thing? Up to 200,000 rows? That's boring. I'd like to give super timeout to Meowcat. Unfortunately, you can't give super timeout. I might have to go download. No, it also has a 1,048,000 row limit. My CSV file is too powerful. Okay. How many redeem slots does a person get? What do you mean redeem slots? Oh, I think you get 50. Something like that. It doesn't actually tell me how many I have. I have a few that are disabled too. Right. So the problem is the folded data needs to be resized based on the size of the packet. So folded data equals packet or new byte of packet size. And we'll set the compression level equals 9. So now theoretically, the output of this operation should be smaller than the input or the previous output by a relatively significant amount. See if it works. No. Oh, I didn't give it the. Hold on. Hmm. Um. Put this in IFMC constants. Do I add ice to my water? No. Oh wait, I can't do this. No. Actually, I could just do this. I don't know. If this is compressed flags, we have to do extra work here. Get rid of this because we're using spans only now. Sorry, does E twice put it in? Oh shit, that puts it in interactive automatically. How convenient. That is a good point. The decompressor is going to have to start using spans too. That'll speed it up too. Actually, the decompressor is probably slower than the compressor now. We could try it. Do you have a command for decompress? I'll try it out in a bit. Okay. I think that'll work. Why is compress flags set to false? Okay, let's see. Okay. We're going to see just how much more efficient this is. I'm saving 2 bytes per update. We're expecting around 7 megabytes of space saving. I mean, 2 bytes on 4, what is it? The entire thing is 70 bytes. It's pretty good. Why would I make an Android app? Money. Slight issue. To list something on Google Play, you need to reveal your full name and address. F-Droid exists. You're not making money on F-Droid. F-Droid requires that your application is open source, so somebody could just build your app and then not pay you. Donate? Nobody's making money on donations. You're kidding yourself if you think people are actually making money on donations. That old people want to use. No old person is going on F-Droid to download games. Yeah. I need to write some sort of flag. Hmm. It is theoretically possible to get any data from the blend shapes that have been packed. So I can't use some sort of flag. I mean, to be fair, it would be incredibly unlikely that you have blend shapes that equal a flag that's decently long. We'll see how this goes. So this returns early and doesn't actually do any of this stuff. The idea here is that this should save a lot of space by, we'll call this origin.cf cl0. Be origin cf cl5 or 4. I just want to see how much this saves. I don't know if it's going to save all that much, but we're going to try it and just see. I think it will likely be relatively insignificant. But if you step away a lot, it could save a lot of space. Actually, it seems to be saving a lot. We're down another %. It saved an additional 16 megabytes of space. Let's see. It starts with 8,480 messages of 0. Actually, there are 1,700 runs of 0 in this file. Huh? This one says it's 345,376. Oh, hold on. So a run of 33, run of 10, run of 1349, run of 82. I mean, technically it's always cheaper to write a run of zeros. Because it reduces the size below the minimum that it could possibly be, which is, I think, 48 bytes. Or no, it's 70 bytes now. Because it's 24 for the floats and 46 for the blend shapes. The only thing that I could do to get better interframe compression is do some sort of bit depth reduction on the values, which I could do, because many values don't change for a very long time. So we could reduce their bit depth to 0, which means that they wouldn't take any space in the blend shape list. But that would have to be a complex prepass. It'd probably be on a 9 compression level. I wonder how these compress with 7-zip though. We're gonna try adding this to a 5 archive. And we're gonna see how that compares to our compression that we had before. Ideally it would be better, but now that we have less of a standard format, it might actually be worse. Actually, interestingly enough, it is worse. This new run length encoding plus combining the flags to make the input size lower actually does make it worse. It is now 58.4 megabytes, or no, it's 61.2 megabytes when compressed at 5, when it used to be 58.48. So slight space regression with 7-zip. Let's try it Ultra, see how that goes. Maybe Ultra will handle it a little better. Oh, I should have deleted the archive first. Or give it a different name. I didn't check to see if I was still using 7 or still using 9. At archive, I was using them. Okay. It is really confusing 7-zip, that's for certain. It is slowing down so much. We're only compressing at 5 megabytes a second. Let's see if it can beat 61 megabytes. Hey, wait, come to think of it, the output is larger than it was before. Hold on. This brings into question the validity of this table. Because SNRC with CF, without any other changes, which is larger than what we're doing right now. Hold on. This process, which is the fast one. Okay, well, it used to be the fast one. Oh, I'm on debug, that's why. Should produce a smaller archive than it is. But it's actually larger now. So there's something wrong with writing the archive. Yeah, because with CF and no other compression methods, we should be seeing 275 megabytes. Getting 344. So something isn't right. Either the floats are not being compressed at all, or something's wrong. What is NC? Oh, no check. Okay. I am curious as to why this is writing more content than it was before. So I'm actually going to... Should still have the IFMC branch. 360. Yeah? And we'll open WinMerge. See if we cannot figure out what's going on here. So the output has expanded pretty greatly. Hmm. Hmm. Is it not compressing the floats? CF is specified. Hmm? Okay, that's 48 bytes. This is 42 bytes. 42 bytes. Two is more than I expected. Shouldn't it have been 24? Hmm. Okay. Next is 6. Come into here. Oh. Should have been AV count. I think that fixes it. No, it's not done writing. You know what the crazy thing is? It's probably going to be faster now that we're not writing extra data that isn't actually supposed to be written at all. the release version is probably like 8 seconds now. We could go check. But my main concern right now is to make sure that this is now correct data. So it should be essentially bit perfect to what it was before. It is the exact same size. And once we get rid of this content, it should be the exact same content. It is not the exact same content, even now. Why? There's 1 byte prefacing it. What I want to know then is, so we're not running full data with flags. And full data doesn't use the flag system at all. So why are we still getting weird values? Let's see. This is compress, floats is true, is packed is true. Okay. Oh, they're being ripped. Okay, no, that makes sense. They're being written little endian. That's why everything looks weird. If I get rid of the little endian flag, it should be pretty similar output. I really should just do this on release. It would be a lot faster. Because the debug is now writing a giant CSV file, just taking a lot of time. Curious to see if it'll go faster the second time. It took 12 seconds the first time, which is pretty weird considering that we haven't actually changed anything. Actually, no, it's writing big endian, that's why. All right, 13 seconds. If we take this again, we delete the preamble, it's still backwards, which is weird. Unless it's just always writing little endian. It's still writing little endian. It's still writing big endian. What is up with that? I mean, other than that, the files seem to be identical. So now we could start putting in all of the weird shit. So CG to compress the flags. Which saves a lot of space, actually. Did not take any longer. Hold on. I'm gonna delete all of these files. I don't know what any of them are. Is that the exact same file size? Sorry, did it save 0 bytes? No, actually, it expanded it. Okay, so it's ignoring the CG flag. What is your deal? I mean, I could set the compression level to 5. That should force it. No, I didn't like that. That's weird. Yeah. So this will be if is compress flags and not a compression level switch. Still not working. It could be that robocopy isn't copying these. I'm not even building release, that's why. Sitting here building debug. Nope, still doesn't work. Okay, we have to go debugging. My guess is that there's somewhere else that I'm checking compression level and not the whether or not the flag is set directly. No, I'm not actually. What's your deal then? Parameter count should be minus flag indices length. Which fixes that, I think. Except for the fact that I didn't push the thing, so it's not going to fix it. Oopsies. Right now it'll fix it. What? Parameter count is now 52. How is this still out of the array? Data equals size 46. Huh? Right, bit offset is 0. The end of the data, isn't it? Oh no, this should be parameter count and not outdata length. Oh, this is gonna overwrite because one of them is at 0, one of them is at 53. This might fix it. Nope. Now it's complaining that all of the data is wrong. Actually, all of them are wrong. Oh, this should be x80. Should be the first bit set, not the last bit. Still, every single blend shape is wrong. $61804 ending in 1700. But the actual blend shape data ended in 170. So for some reason, the output data this should just be I think. I think that works. Because it's writing it into the wrong addresses. Yep. Okay. Now it's not complaining and blowing up. Oh, that's why it's slow. It's because it's checking. It doesn't need to be checking. It's because I changed the flag to NC. We'll turn off checking. So compressing flags. How much data did we save? Save 7 megabytes, which is about what we expected. So now going to add the run length encoding parameter, which will skip any updates with tracking data set to 0. Which is probably going to be slower because it has to do a string comparison. But it also means it'll save more space. Because those get rewritten as like a 10 byte message. So that saves a decent amount of space. Now we can run our 7-zip tests. So we'll add CFCG to a normal mode archive. And we'll do the same with this, which is CFCG RLE, which we will send as an archive and see how that performs as well. It should be better. Interestingly enough, both archives are larger than they used to be. it's actually once you put it through 7-zip, it's a regression and not an improvement, which is strange. We'll do a quick sanity check. We'll add the original archive to a 7-zip file and see how it does. So I think the problem is that now that we have reduced the space usage, it's more complicated for 7-zip to try to look for like commonalities. So it ends up actually being larger. So what I want to try is, what if we do not CG, but we do RLE. This should be very minimal changes. Because 7-zip is literally built to do RLE and that type of dictionary stuff. So it should be almost exactly the same archive size as the output. But it has a lower input size, so it ends up being better. Then we have to make the decoder handle these files, which it currently does not. Interesting. Even with the run length encoding going, we actually do have a size penalty there too. 59.2 is 700 megabytes larger than the input. 700 kilobytes larger, sorry. Which is weird. I don't have the compression level set, do I? No. Interesting. It is worse compression. I do have a couple other ideas on how to reduce the size quite a bit. But these don't seem to be very effective. Okay. So what we're gonna try to do now is I just want to try one thing. So I kind of want to take another look at the output if I have one. Here, let me open debug. Accidentally run it. I want to set a U limit really quick. U limit equals 200,000. Because I need a CSV file to do this check. All right, we'll take the first 50 minutes of data. You would have to pre-pass this. Actually, tracking status is implicit because if a message exists, tracking status is 1. And if it does not, then tracking status is 0. Um, hmm. I don't know how I would do this in one pass. The idea was to do essentially run length encoding on the parameters. But with it being a packed byte array, and without having the ability to seek the file, it's kind of difficult to determine. Because I could build an index of it. I mean, I guess if you're on compression level 9, we can go pretty crazy with the memory usage. So we could keep an index of every one of the parameters. What's the memory usage of that for this file? How many updates are in this file? If I get rid of the update limit, and I run this again, we'll do it on release so it doesn't write the thing. There are 3.8 million updates. There are 54 properties, which is 206 megabytes. Hydrate? How could you? No, you drink. Hmm. Right now I'm thinking about ways to improve the compression and make this unnecessarily complex. Because with the prepass I could just make a giant table of all of the blend shape values. The question is, how do I do this in a way that is sensible? I mean, looking at the data, right? You could totally do something. I wish I could graph these because I could show what I mean. But essentially, the idea is that the values don't change very much most of the time. For most updates, the changes are within the range of maybe 32, maybe 16, and for a lot of them as low as 4. And you could reduce the bit depth of every single parameter and write its offset from a specific known value. So by reducing the bit depth, you make it possible to save significantly more space. And we could write some updates with 0 bytes. And some updates with as few as like maybe 3 for the parameters. The main thing that we can't really save is the floats, but this is a way to save a ton of space. I just have to figure out how to do it. Making me drink again. There is some potential to make an extremely concise format for this. Trying to keep me alive, yeah. I had one day, I was like, everybody was making me drink on stream and shit, and like the stream ended, and I was like still dehydrated. I'm like, what the fuck? I drank like 3 liters of water today. I downed another liter and then went to sleep. But yeah. Now I come to the problem of, do I want to do all of this wacky compression myself, or do I want to just make 7-zip do all the work? I could theoretically beat 7-zip. And it would be very small. The only problem is it's going to complicate the hell out of the compressor, and it's going to complicate the hell out of the decompressor. It is going to make them very complicated. And they're already relatively complicated. Sounds like a do you want to debug that later question? Exactly. I mean, it's already extremely small. We're hitting data rates of 6 kilobits per second. I don't need to go lower, but I want to get every byte. It's like, it's almost like code golf now. It's just it's for sport. Why is it not letting me change this? Compress float of actual values at I. Okay. I could just do this directly. I don't know why I save it to a variable and then do the thing. I wonder if I could do... Yeah, no, it's just for bytes. But this is a float array. But yeah, I do kind of want to like clean up the file here because this is really messy. Hold on, let's do some cleanup. Before cleanup. Ooh. Okay. So first things first, I want to move prepass to the bottom of the file. Right header doesn't actually have an implementation. We don't actually write a header at all anymore. So I'm going to remove this because the header is written by the container now, and it's not written by the file. So we need to get rid of right header entirely. That does mean that the VMC compressor is no longer going to work. But honestly, I'm gonna have to rewrite this anyway because we've changed the method it uses to write things. Let's make it not overread. I don't even think it was ever called. Calls in try-move stage 1, but we don't write the header, so that's okay. All right. So check folded blend shape data. I want to change this to be static. We only need to know... Actually, no, we do need to know quite a bit. It can't be made static. Verify folded data. Actually, I think do expand float. Shouldn't it be expansion? No. Okay. I mean, we might as well check this, but this should never include spans that do not include hashes. But we do need this hash anyway, so we have to get its index. We might as well check to make sure the index isn't -1. Okay. There's so many so many different variables here. BS vals. I mean, we could just do this. So now in prepass, when we assign the number of flag blend shapes, we can now also define, we do it with bs vals.length. So we're just going to set it to n blend shapes equals values.length -3. Is it a byte? It might be a byte. I forget. I already don't know. It is a byte. We could make it an int. That's fine. I don't think them being bytes actually helps at all. This is great content. Thank you. Also, welcome. Have I considered installing Arch Linux? No, not Arch Linux. I have an admission to make. Chat. The allegations are true. I use Arch, by the way. Or at least I have used Arch, by the way. I've moved to MX Linux. Arch Linux is so painful. But I have been, I was going to say an archer before. Arch is great. Arch is great if you know how to use Arch. And you really like the AUR. And you also trust everybody in the AUR. Of which I do not. The only slightly confusing thing about Arch is Pac-Man. See, that's my problem. It's Pac-Man. Pac-Man sucks. Yeah. I don't know. I've gone to Linux several times and I always come back. I just have a lot of trouble with it. Though I do still use Linux on my laptop. When is this written? This is written in prepass. We only read it afterwards here in compressed packet. So we actually don't need to give it its emergency reset here. It will always exist. I will do it anyway, though. Pacman is still way better than apt? Why do you say that? Apt so verbose it takes forever to type a command? What? I don't think it is. Just do apt install. It's not gonna apt install the shit. I would argue apt is better than pacman because the command to install something with pact or with pacman is S for install. S for sync. It's not a good name. I will die on this hill. Sync is not a good name for that. When you go to install software, the last word you expect to type is sync. They would do really well to add like an I flag or something. I is probably taken already, but sync sync yes everything. I like that. I need to like I want to organize the shit. There's so many things. The indices of flag blend shape values. If C is compress flags is enabled. Empty otherwise. The values of each blend shape. The folded blend shape data. Press flag blend shapes to the beginning of the folded data with a size of 1 bit, or with a width of 1 bit. If true, IFMCC will summarize updates where tracking status equals 0. Contains the maximum observed error of the float compression. Always 0 if CCRF is compressed floats. CRF completion provider encountered an error. Damn. All right, rote header is actually not necessary because we already know that we. I mean, I guess it's used to. Hold on. This is only used so that it doesn't regenerate the header every single update on the pre-pass. Pre-pass determine characteristics. I don't know. Doesn't have to be a good name. Isn't this written to? Oh, it's aliased and then written to. Isn't check should be a property? I know it's not because it's not part of the flags, so it isn't a property. Okay. Oh, you want to see my favorite thing? We generate a table of all of the byte values as strings because it's faster than doing byte.parse. it's actually like quite a bit faster. This should probably be done in the constructor and not in the pre-pass. So we'll put it there. It's one of the things we need to fix a bit of is that the pre-pass is where we used to do all of the object setup. We should probably fix that. Because this has to be done here because we don't know how many blend shapes there are until we parse the first byte, the first packet. Is this value list ever used? No, it's not. We don't need this. It was used back when we wrote the header directly, but now the value list just isn't used. I could do spans and stuff here, but I don't think it's necessary. This is a little bit slow, but it's only done once. Okay. I think that that's good. Could make this like a helper thing. No, hold on. I feel like this file is so messy. But I think that there would be performance implications to adding a bunch of jumps. We'll see how this goes. I did just spend forever optimizing the performance. What are my flags? My flags are run length encoding, which we'll disable for now. We'll turn on Actually, we'll just do it with the original stuff and see how it performs. If I've caused any major performance issues. "11 seconds" is a little slow. It is worth noting we are processing a 19-hour input file. Or a 17-hour input file. Interesting. So it's 10 seconds, 292, 10,292. We'll turn on CG and Arly, which are the two new things that we set up. Curious to see if it changes. Huh? What? It absolutely tore through the file and wrote nothing. Okay. That's weird. Why is it skipping the entire file? Oopsies. Yeah, clearing the byte table, now that we do it in the constructor, not in the prepass header, means that there's nothing in the byte table, and thus every byte is 0. Tracking status is always 0, and nothing ever gets written. Anyway, now that the thing actually works. Okay, we'll run it without the debugger. All right, seems to work pretty well. 7% is better than I thought we would get. Should we get 10%? Okay. Do I want to make it do the thing? No, I do not. Okay. We now need to make the decompressor capable of decompressing the input data, because right now it can't. Because we have changed not only the header, we've also changed the file header and the data format. So now what we need to do is we don't need to know if it is big endian or not. We have a function read big endian, and we don't need that anymore because that'll be done by the input directly. So we're going to take all of these, and we're going to do them directly. So it's just going to be okay. Let us check the SNRC header version. Yep, all of this. My facial mocap is blend shape value count as a uint16, packet size as a uint16, flags as a uint32, max error as a uint32, a list of blend shape names, and do we want to make it that it probably won't change? We're not going to bother about changing the blend shapes to be a dynamic list. I don't think they're going to update iFacial mocap. Is Arlie encoded? There just is no tracking Arlie. Okay. We're going to have our work cut out for us because I'm pretty sure this is really old. And it's going to be entirely wrong. These have already been reallocated, so they don't need to be reallocated again. Because the first thing that the decompressor does is resets itself. Yeah. This is no longer true, so we're just going to delete it. The documentation is now the best. The hard part is we need to read the header, which means we need, and this is going to be a thing in all decompressors. Essentially, I've changed how we do the decompression. It's no longer done. It used to be we just give the decompressor the file and say go wild. Now we are actually containerizing it, and now we need to actually give it information. So in decompress, we need to give the decompressor equal to set container, our container equals new reader.basestream. Does this read information out of it? It doesn't, does it? No. We need to do public static SNR container from stream. But yes, how you doing today? One of the last times I worked on a decompressor was reverse engineering a decompression function using Ghidra. That sounds painful. Right now, I'm just so essentially I have a tool I use to record my model's movements. because it's more efficient than recording the video of the model, and it's more flexible because I can replay the data if, let's say, I'm off screen, right? I'm all the way down here. I can move the model and then just replay the data. The problem is it's not large, but it could be smaller. I was trying to handle assets from a PS2 game from 2002. Oh, nice. What game? Treasure Planet. I don't think I've ever heard of that one. Also, here's the compression data. This was a 3.7 gigabyte file. We got it down to 275 with some pizzazz. It's based on the Disney animated film of the same name. Treasure Planet? I mean, I'm not a Disney buff, but I've never heard of Treasure Planet. Huh. I feel like I would have heard of it by now, right? Treasure Planet was inspired by Treasure Island. Yes. Yeah. Does it give me a way to set? It doesn't give me a way to set how many bytes I compare, does it? Can I just read directly from? Hold on. Adds on for a minute. Okay. I need to make a way to read big. They kind of butchered the story. Damn. Pretty much a somewhat meh clone of Jak and Daxter. Damn. I don't think I've ever played Jak and Daxter either, come to think of it. I mean, I've seen it. I think I've seen speedruns of it. I've never played it. What is the best way? You know, fuck it. String magic equals encoding dot ASCII dot get bytes of buffer. Not bytes. Shit. Get string. If not magic, if magic does, no, it is not magic dot equals SNRC ordinal. Throw new invalid data exception. The stream does not represent an SNRC container. All right. Now we can get down to the fun stuff. I need to go get the header. Header is SNRC. Header version as uint32. Converter.get bytes. I think this works. not get bytes. Get uint32. Despite that, I managed to make a 99% complete level importer for Blender in the game, or for the game, and also an exporter. The exporting is more like 75% complete. That's cool, though. I always think it's cool when people mod old games, because it's like breathing life back into it. Where is container.flags equals bitconverter.to uint 64. This is like kind of bung, but we're just gonna ignore my problems. Why is this not working? Oh. That's not the type. Oh. Shit. Okay. Trouble is, I have to figure out how precisely they optimize how precisely they optimize level geometry. I figured out how to export the geometry itself. There's some optimization trees I have to get right. Yeah. Like, reverse engineering file formats is a lot harder than making your own. There we go. And this just becomes just return value. That's fine. Use some binary spaced partitioning tree implementation for the collision triangles, but my attempt to implement BSP trees for it did not match, I don't think. Yeah, do you have like a good way to like visualize or like debug? Like see. I'm trying to think of how you would debug it. You'd have to have some sort of like way to visualize how your algorithm is doing it and how their algorithm did it. I don't know if it exists or not if I do that, so I'm just gonna explicitly create it. Data length is set, file type identifier. Actually, this is encoding.ascii dot get string. Is it a character array or is it string? It's a character array. Get characters of br.read bytes of 8. Nope, 16, not 8. I'll get back to it eventually, kind of been on hiatus in that project for now. Yeah. Oh, that's another problem. We can't do polymorphism here. Never did implement a recompressor for the game files. I have been doing a lot of recompression lately. I've been doing a bunch of recompression. I don't have to technically. I mean, that is true because you have, if you're playing on emulator, you don't have space limits. So the problem is the subheader has a length and a content. I might have to make a container for it. The game can load the assets compressed or uncompressed. Oh, nice. I mean, we could just make public class SNR unknown header, SNR header, public ulong pointer. So we don't know its pointer, do we? I mean, yeah, we do. Pointer length, public byte array data. The container dot extension header equals SNR unknown header. Actually, the length is what we set first, equals this pointer equals br.basestream.position as a ulong, and data equals new array. Actually, we could do br.read bytes length. I mean, I could just inline this. Did test it on my PS2, though not on the disk. My PS2's disk reader has been dead for ages now. Instead, use Homebrew from loading them from USB. Nice. Yeah, the disk drives usually fail. Also tried an Ethernet solution too. The PS2 had Ethernet? Was it a network-enabled console? Was the first Monster Hunter game PS2? I cannot remember anything. This is going to be exactly the same thing, but subheader length. We do not know anything about the subheader. And then the next is just the data, which we don't have. Header locations, HL. What's new? HL.extension header pointer equals br.basestream.position. Slim PSUs had an Ethernet port on the back? Damn. They got the Ethernet support pretty early. Ah, that's where the trade-off is. That's rough. All right, I think we have set everything. Header version, we haven't set header length. We actually don't even we don't even use it. Yeah. Does the PS2 have a mass storage driver? I think so. When I open the Homebrew file explorer, oh yeah, then the Homebrew like app probably has some mass storage drivers. Okay, throw this up here. We can now obtain a stream from, or we can now obtain a container from a stream. We don't discard the header. We set the container for the decompressor to SNRC. Read header. We can now obtain the header's information. Wherever read header is. Oh, this is the compressor. Could be interfacing with something the PS2 has natively. Yeah, you are right. It does come with USB ports, so it may have native USB support. I haven't looked into actually developing PS2 homebrew myself. Yeah. I have, however, looked into studying PS1 homebrew. Yeah. I always feel like it would be better to do it on like the latest system, right? You know, you get the extra power. You don't have to worry about memory so much. How do I want to do this? Memory stream ms equals snr unc or new of snr unc dot data. ms dot position equals 0. I think it starts at that, but I don't know. Big endian. Oh, I don't have that. Fuck me. Okay. Binary reader br equals new of ms. I don't know the encoding. We're just gonna ignore it. I had a particular goal in mind that only increases worries. I didn't want to develop homebrew for PS1 disc. Are you gonna try to make the like isn't there some sort of homebrew that uses the memory cards? Is that perhaps what you're doing? I actually don't know if these files are written big endian or not. Are they written big endian? I deleted the headers from both of my examples. Shit. Technically, the entire header of an SNRC archive is supposed to be written big endian. And I don't know if it's doing that. It is written big endian. Okay. I did end up having to read this backwards like this. Whatever I make, I have to fit it within the 128 kilobytes of a PS1 memory card. See, this is okay. I know the PS1 doesn't have an Ethernet port, does it? I was gonna say you could just have it download everything from the internet. Is this considered part of the header? Yep. Yeah. I mean, that's pretty cool. The way that I think that I could do this more quickly if I read this as a byte array and then just use the ASCII thing. But the thing that I'm going to use here is the power of saying, I don't give a shit, this happens once. I got inspired recently and made something a bit bigger. What did you do? I'm afraid. Oh shit, we don't know this either because the folded blood shape data size. We have to do argument parsing already. Alright. A Game Boy emulator. In the 128 kilobytes of the PS1 memory card? Huh. we have to do some thinking here. So blood shape data size is not this. It's actually the packet size minus 24 or 48, depending on the compressed floats. Yeah. Managed to make an interpreter-based Game Boy emulator with less than 40 kilobytes. Oh, nice. And you can load an entire ROM. I wonder what the minimum amount of memory usage of a Game Boy emulator could be. It admittedly ran like shit. That is unfortunate. I don't know if this writes blend shape count. Is it 54 or 52? I actually don't have any fucking clue. It's on after pre-pass determine characteristics, it's end blend shape, so this doesn't include the flags if that might be a problem. I did get it running well using DuckStation by removing the frame cap, allowing it to run like 35 to 40 times faster than a normal PS1. Just imagining you load up like fucking Mario and all of the Goombas are flying across the screen. You know, that would be a good ROM hack. It's just Mario, but they make the Goombas 10 times faster. Damn. Yeah, that's when you gotta optimize it. I mean, I just spent yesterday taking this IFMC compressor and optimizing the shit out of it. And it went from 47 seconds for a 19-hour input file to 10. So I saved a lot of time, but I did make it incredibly complicated. Was it worth it? I don't know yet. Yeah, JIT would probably do a lot. Sounds really complicated though. Especially with so little memory, because you can't store so many usage characteristics. learned recently that the Nintendo 64 emulator ran on the GameCube for the Ocarina of Time and Majora's Mask boards used JIT. Did they ever get the FPS above 20 on the GameCube? Because I know that the game used to run really slowly. But I don't know if it was limited to 20 or not. I know that with Super Mario 64, they left compiler optimizations off. And that's why the game has a slightly wacky frame rate. Blend shapes, I didn't write a D. Alright. So we also need a private custom engine sandbox. Sandbox? Or Unity? I have made my own engine. So I guess custom engine. I have deleted it. I don't want to talk about it. I'm like, why does it keep putting a P? I look down, I'm actually pressing P. I'm like, oh no. Chat, I might be a little stupid. Just a little. Hello, Ninja. How are you doing? Might be cooked. I might be slightly, completely fucked. Do I have sufficient caffeine? I mean, I could go make coffee. I probably should go make coffee if I'm making mistakes like that. I've never looked into JIT or any other compiler stuff. Yeah. I haven't looked into compiler stuff either, but I kind of do want to. I have a slightly ambitious programming language project. It is a terrible idea through and through. If you thought JavaScript was bad, this is going to be worse. Oh, by the way, you can't say JavaScript here. You also can't say Python here. Those are your two warnings. You can't talk about those two programming languages. My automod takes no prisoners. What about TypeScript? I mean, it didn't kill you. we have an auto mod that will, if you say it's job 6.7 Python JavaScript or chicken jockey, it will annihilate you. How about Unreal's new scripting language? I actually don't have Unreal installed. I have never looked. But my programming language it's a really bad idea. It's a programming language where you can add new language features in your files. So, you know how you have like try catch? You could make one called fuck it. And then you have to deal with what happens in the closure of fuck it. So it's a great idea because you can remake basically any programming language by adding your own language features. And it's going to be so complicated on the back end that thinking about it should be a crime. So we called it thought crime. We're not even halfway into the figuring out how it works stage. Because honestly, who the fuck's going to use it? It is a terrible idea through and through. But it would be so cool. I'm migrating from GitHub to GitLab. I have a custom .NET Core CLR, custom GC, C# projects, driving LLVM JIT, and embedded bitcode modules. Damn. You've got the full kit. Finished embedding servo into my rudimentary game engine. What is servo? Servo is Firefox? Oh shit. Nice. An entire browser in your game engine too. My game engine is super bare bones because it's meant to be played on like incredibly low-end hardware. So my engine has a design limit of 128 megabytes of memory and 32 megabytes of disk space. On terrible ideas, I'm trying to make a world simulation text adventure. Might benefit from SciGC then. SciGC. South Australian Italian Golf Club. Unfortunate. It's a custom GC. I actually don't have garbage collection at all in the engine. And it's performance focused enough that we actually don't even use smart pointers, which is a terrible idea. But yeah, we just kind of run it. We're using B0. We just don't have a GC. It's C++. B minus. B minus. Yeah, it's C++. Yeah, the engine is in C++. It is incredibly, yeah. B flat. That's my favorite. That's my favorite note. But thank you for following. C# without the GC? That sounds painful. How do you delete things then? Because I know in C# you can't explicitly delete things. Unless they give you, like if you set an array to null. Thank you for following as well. If you set an array to null, it actually gets deleted. That's one of the things that kind of bothers me about C# is you can never delete something. And I really wish that you could. We have stack alloc. Adds manual tombstoning to C#. Oh, nice. Also, yeah, you did get censored twice in that message. If it detects a link in the message, it'll delete the link. It'll just put it 3 asterisks. The links native memory.alloc and native memory.free. Oh yeah. That is true. I could do native memory allocation. But yeah, my compressor here uses a bunch of stack alloc. I just yesterday I ported everything over into spans. Mistook you C++ for C#. No, this is C#. I'm not working on the game engine right now. My C++ is significantly worse. It is a lot worse. I could open it. Let's see. See if I can find it. Huh? Have I never opened it on this computer? Maybe I haven't. Hold on. It should be on the programming drive. Yeah. No, I swear. It's C++. Here. If you want to see my absolutely atrocious game engine, I must warn you, there is some trash in here. But yeah, here's my game engine. Here's the string thing. Essentially, I was making a game, and then the project died because I ran out of money. So, but here's my string. It is certainly one of the things of all time. What? I guess this doesn't support scientific notation, does it? Eh. Nobody uses scientific notation anyway. What is the most atrocious? I could show you compile utils. Compile utils is fucking. Look, if you like good programming, you might want to look away. So I have all of my things to tell Windows to fuck off, right? But I have I have some black magic, which is I don't want to use. Where's Win32 lean and mean? Right here. I didn't want to have. So the design of this is that I should be able to do it without using any like additional tools. Ideally, this should build with GCC and nothing else. I mean, I use MSVC, but it should be able to build with no like secondary preprocessors. No Clang. I haven't actually tried Clang. Right now it doesn't matter because the thing is Windows. It only works on Windows. I don't actually have support for Linux. Because I don't have a way to test it, and the project is dead, so it'd be not worthwhile. And also attempting no WSL. I mean, I could do. I don't know if that's gonna work though. It seems a little janky. I'd probably just cross compile it. But the other major reason I haven't put any support for Linux is that I was gonna implement OpenGL, and OpenGL is a fucking nightmare. It is so bad. But yeah, essentially this is my hack that I can set a profiling level, which will increase how much the engine is profiling certain things, and without having to use a preprocessor. Yeah. I just have a Linux server, so if I need to test something on Linux, I could do it there. But yeah. This is my black magic for profiling, which is also done for assertions. And the top one is called actual fucking pedantry, which is everything is being checked. It is incredibly pedantic. And that's there for if something gets really wrong. I mean, this was implemented after probably 75% of the engine. So it does actually have to be, I have to go through and update everything. But the idea is if something is going wrong, this will check even very simple things. For PS1 executables, I compile with MIPS, Linux, GNU, GCC. Yes. Leverbose. Yes. But there's actually not a log level. Yeah, then we have some weird utilities. Same energy as VVV. Yeah. There's a bunch of really bad ideas in here. Like for, where is it? Util location. So, in my game engine, you have 3 types of locations. You have game location, tile location, and render location. I really shouldn't have done that. But the idea is that you can convert between them relatively easily. So if you want to draw an object at a certain game location, you could just cast it to render location and it'll be correct. It'll be the actual screen space coordinates. It's kind of nice. It's just really complicated. And the same with tile locations is meant for the tiling level system, which I'm not sure if I'm going to keep it in the engine, honestly. It's primarily the engine was made for a side scroller. And it was halfway through splitting the engine from the game itself that I realized I probably shouldn't have an inbuilt like level type like that. I wouldn't have declared implicit conversions like that. Yeah, it is convenient though. Are these even implicit? I don't remember. Maybe. I can't remember. It's been so long since I worked on this. Realistically, if I do make a game, I'm probably going to use Godot anyway. I made this because Unity shot themselves in the foot and canceled 2 of my projects. With the whole pay us every time somebody installs your game thing. Because I don't know about you, but I have no money. So I can't afford I can't afford paying Unity when somebody installs my game. And I also don't like the idea that they just retroactively add transactions. So I never use Unity. So I made my own. And this was half to make my own game engine and half to learn how game engines work and get information or like get experience with them. But yeah, that is part of the thing. We have DirectX as our major renderer because it's the only one that I have that works. Because OpenGL is pain. But the architecture of the engine is in such a way that okay. Let's say you have a game, right? And it's really old. And let's say it uses DirectX 9, right? And let's say for whatever reason, DirectX 9 is no longer supported by graphics cards. It has been completely removed from support, like Windows Mixed Reality. So the thing is, the game engine includes an interface for graphics. So where do I show this? So we have like interfaces. So as long as you can provide a DLL that supports IE2D renderer base, any game that uses IE2D renderer base will work. So the idea is that if you have a game that doesn't work and you can provide a new provider for this interface, you can play the game. Can't help but wonder how Unity would enforce that crap. What about mods made for existing Unity games? Yeah, with their trying to extort people, really. It's John Rositiello. And good riddance. Now he's going and fucking up Pilates or something. John Rositiello. You know what? Fuck it. You know what? Oh, it didn't answer. We're going to make John Rositiello. I don't know if I spelled his name right. Hold on. Nope, it's 2 C's, 1 T. Okay. We're making him profane. If you say his name, you get banned. What? Oh, I only copied his last name. Alright, if you say John Rositiello, you get permanently banned. That's it. I don't like this guy. Get him out of here. If you say his name is a swear, I kind of like that idea, calling somebody a Rositiello. We might have to allow it. Why am I awake? Why are you awake? Go to sleep. I'm gonna. You know what? You've convinced me. I'm removing John Rositiello from the banned terms list. Time zones? Yeah. Casually check to make sure I have actually removed him. Nope. Oh, I got rid of the one that's spelled correctly, but not the one that's spelled incorrectly. That's okay. All right, but yeah, this is my game engine. It's pretty wacky. But yeah, the main other feature of it is that where did my oh here it is. They're all interfaces. So the sound system can be re-implemented with new APIs. The 2D renderer, if ever I decide to make a 3D renderer, God forbid, we could do that too. What could Unity enforce? So they were talking about we were talking about how Unity made it so that you have to pay them per install. And Colt was asking about how they would enforce that for like mods made for existing games and stuff. They'd probably just bill you. They probably have some sort of message it sends when you open a Unity game. They'd find some way. Yeah. You had like the big a big movement of buy my game but don't install it. It's just it's so disappointing more than anything. Alright, I need to make things do spans. Flag indices needs to be initialized to the number of flags equals new byte of n flags. It would require tracking that's probably illegal in the EU anyway. Yeah. I mean, they'd probably do it anyway. You guys do have all of the chat control stuff going on. Didn't that pass? Chat control is a proposed law. Yeah. I don't want to get into modding Subnautica, which is a Unity game. As long as they don't use IL to CPP, it's super easy to mod. It's like trivially easy to mod. Because you can open the assembly C# in .NET Spy and just edit the fucking code. It's so easy. I love Unity games for modding. I hate making them. OG Subnautica is pre-IL to CPP. Yeah. Oh dear. Are you gonna put a Game Boy emulator in Subnautica? Oh my god. IL to CPP's metadata can be decompiled to C# rough assemblies, so you have the interface for everything up front. Yeah, but it's more difficult to edit the game directly, which is typically what I do. I'm too I'm too lazy to actually do things with the game directly with its interfaces. So we need to make spans. Actually, I guess we don't have to. What even is the decompression performance like? I need something that is not CG or RLE. I'm curious to see how the performance of this actually goes. Yeah, but the problem is I have to understand how to use Ghidra. And my dumbass doesn't know how to do that. I have to update the plugins. I have opened Ghidra before. That's about as far as I've gotten. I mean, they say opening is half the battle. They're wrong, but opening is half the battle. If I tried to make an emulator for one of the fictional devices in Subnautica. Huh. Yeah. Opening Ghidra is 3/4 of the battle, you're right. It is very labyrinthine. Huh. Oh. No, that's not the right process. It's IFMC Decompress. We're not even touching the VMC shit yet. It still didn't work. Get extra status information. Mm. Oh. You can tell somebody somebody copied this code and didn't check to make sure that it was right. Mm. It's pretty fast. It's about an hour per second. I mean, we also do need to make sure that the output file is correct, which it probably won't be. No, the output file is actually too small. I feel like the Subnautica PDA is a bit obvious. Have it be on the fabricator. You open it instead of the menu of the items it opens. It's just like Mario 2. I now need to figure out why the file is not correct. What the hell do you mean not enough memory to load file? I have 21 gigs left. Well, there goes one merge. It's dead. Okay. We're probably going to have to do a smaller thing. So we'll do U limit equals 180. Yeah. Huh? How is the output data that much larger? Oh, fucking dumbass. It's larger because one of them is compressed and the other one isn't. I might be a little bit stupid, guys. I need to use the old IFMC compressor then. SNR2, IFMC, compress in equals origin.ifmc.snrc, which I have to quote because PowerShell is trash. Out equals origin.ifmc.snrc. Wait, the input is not compressed. Sure. Ulimit equals 30 or 180 CF. Should be good enough. And then we decompress that. Eh? Oh, hey, look at you. You know what? We'll add that string to our ban list. Anyway, begone thought. Sounds like fatigue? No, I'm just a little confused. Did it work? Okay, so we have our out. Okay, they're definitely wrong. What is going on? One of them is what, even? Yeah. Oh, I turn on word wrap. Wrap lines. Let's see. It's a bunch of like trash at the end of the file. Or is that the end of file? Oh, it's the end of file. So weird. Uh-oh, what have you done to me? Oh, I am very, very, very bright. Hey, Tune. I might have compressed these with different settings. That's the biggest thing I'm thinking right now. Ulimit is 180 on both of them. Why is one of them 1/3 as large though? Object reference not set to an instance of an object. That's so wacky. I can just use the old one, if that works. Okay. They are now nearly the same size. That's good. So the reason that it was wrong is because one of them was slightly broken. Is there just like 30 new lines here? What is happening? Let's change this to a binary comparison. All right, load in the original. the new. Okay, so if we go to the end of file, the right side is slightly more compressed, and I don't know why. That's weird. The floating point data is entirely wrong. It must be being expanded with the wrong factor, is what I'm thinking. Because it's going from -2 to -178, which is not close. So let's see if we can't figure out why that is happening. So expand float is S times retraction, which is 180 over 327, 67. Oh, the decompressor doesn't use that, does it? It does technically use it. It could be desynchronized. It could be desynchronized. Let's see. The input file is compressed floats without any compressed flags. I have to build the plugins again. Debug. Okay. So folded blend shape data size is 48, which is correct. -178, huh? Let me try something here. What if I just... We're going to try reading it forwards. I don't think this should fix it, and it shouldn't fix it. No, it should fix it. But for the wrong reason. It does fix it, and for the wrong reason. Okay. If we refresh this and reload this file, it should be correct. And it is. It's actually identical, which probably means that I loaded the wrong file. Okay. The original on the left, the new on the right. Are they actually identical? Shouldn't be. Maybe the difference in file size was only because they were... Oh no, it does make sense that they're identical because they were both decompressed. So they're both going to have the loss of accuracy already. But if I were to take it from the beginning of the actual input file, it would probably have slight differences, which is what I expected. Okay. So input is not big endian aware, and it's supposed to be given by the input. So in decompress, we need to change input to be a big endian source binary reader if the little endian flag is not specified? No. Okay. If argument stuck at little endian is not null, or snrc dot flags dot is little endian. So it'll attempt to automatically determine. It should be big endian source binary reader is reader dot base stream reader equals best br. Oh, it also doesn't inherit from binary reader. I had some reason I did this. Can I override, or do I have to do new? I can't do that for dispose. Okay. We will override explicitly all of this behavior. It would help if I collapsed to definitions. Really could have just replaced public with public override. What? Does this not just call itself? There was something in that. These aren't. Oh, this needs to be duplicated. Because only read forwards being in its. This will just default to this. Okay. It's a little jank. Just a little bit, but it should work. If we decompress, the data should still be correct. Maybe. It is still correct. Okay. Now, if I force this to be if I force this to take the other path, it should give me a bad file. It did not. Is it not running this? It should be setting it to a big endian source binary reader, which should be is little endian is true. Reverse endian is false. Oh. problem. It doesn't work with big endian because the thing isn't actually ever changed. So it's still writing and it's still reading from little endian. Unit tests? One day. One day. This is slightly bong, so we will get there. My unit test is seeing if the app doesn't blow up. The problem here is that reader is discarded and is finalized, which kills the base stream, which is the file stream. Which I don't know if I can actually fix. I could set leave open. I mean, I could set leave open. I have a reference to the input stream. Contractually, there's no contracts here. We will set leave open to true. Same up here. Yeah, when I have everything working at a base level, this doesn't support leave open. Does it make sense to have it leave open? All right. Bool leave open equals false. And we'll set this to that. Okay. And then at the end of execution, where the hell did my thing go? All right, at the end of execution, reader.close, writer.close, error.close, instream.close, outstream.close, errorstream.close. Oh. Didn't happen. Okay, read forwards is false, which we expect. This should crash. Not for that reason. Cannot access a closed file. Where? Oh. I closed the console. Okay. Easy solution. Okay, now I'm confused. It's still throwing an exception that there's a closed file. All right, new plan. What? Okay, hold on. Let's rebuild our plugins and try that. That could be causing an issue. Could also be why it's not telling me where the... Okay. Show call stack. No information. At do line 463. Yeah, it's saying that it's throwing it here. It's an object disposed exception, which is weird because we don't dispose anything. Unless it's one of the, we should probably, yeah, the build succeeds. We should probably, like, actually make some unit tests. You're probably right. Boring unit test time. Add new project. I should probably just make an actual library. Hold on. Maybe we fuck off to a new project and make a big endian. There's my build success message here. It would warn me. It opens a window if the build doesn't succeed. Here it is. Rebuild all 11 succeeded. There's a lot of warnings, but we don't worry about that. But yeah, I would know if it didn't succeed. We might just go and make a NuGet package though. I mean, we could just do it here. Or I could just look for one that does big endian. Hold on. Okay, so we're gonna make a class library. I'm gonna call it big endian big reader. Big reader is what we're naming it. That's it. That's the name. Big reader. All right. Public class big endian binary reader, which is going to inherit from binary reader so that you can assign it with polymorphism. We're going to generate all of the constructors. We're going to... Alright, so big endian binary reader. A binary reader for big endian sources. We could theoretically make a variable endian binary reader too. So I want to override every one of the binary reader things. These are all virtual. So, I mean, we could just take the code from the other one. It's time to yoink from my really, really poorly implemented big endian source binary reader. Okay. This will be handled by the base. Base stream is also handled by base. Is it? Hold on. Base stream. Yeah, I do have it. Wait, that's because base stream. Am I allowed to edit this? I am. Okay. So we don't need this. I'm assuming binary reader will handle complaining if it can't read. Yep. Okay. So we don't need to override close or dispose for that matter. We do technically have 2-byte arrays, but they're 16 bytes, so I'm not really worried about it. Equals, we don't need. Get hash code, we don't need. Here's where we get to the wacky bits. So let's get rid of all of this trash, which was removed. So I'm just going to assume it works as is. Essentially, this the big endian source binary reader was made because the VMC processor is built off of a library called Core OSC, which used a bunch of lists of D words for its major processing. And I changed it to use streams instead, and the entire thing is big endian, which is why this thing exists. It was really poorly implemented, so hopefully at the end of this we'll have one that doesn't suck ass. So the idea here is that private static bool is current system big endian is bit converter dot is little endian is false. Okay. So if the current system is big endian, we want to read forwards. And if the current system is little endian, we want to read backwards, is the idea. So private int read byte buffer int index int count read and reverse read and read to system endian is going to be essentially this text. So read forwards is current system big endian, or reverse endian does not exist. Also, what was that? Oh, thanks for the follow. So if is current system big endian, we just read straight in. Otherwise, we have to do it the backwards way. Heading off? Oh yeah, thanks for stopping by. We could probably do this with a span. This would probably be faster as a span. So a lot of why this is probably really slow is because of allocations of buffers and stuff. But yeah, good night. And good luck with your Game Boy emulator in Subnautica. Let's see. You know what? Maybe we just do spans. Span of byte. Buffer. All right. If I mean, we don't even need to worry about reversing it. No, we do. Shit. If buffer.length is less than 16, read, or not read only span, just a span of byte memi. If the length is less than or equal to, I mean, we could probably do less than or equal to 256. Then actually I want to do another thing really quick. Read bytes forwards. We'll just do this. Okay. Memi equals stack alloc byte array of buffer dot length. Huh? Great. There is no help for that error. C8353. CS8353. Apparently you can't reassign a non-stack alloc span. Okay. Okay. Else equals new byte of buffer at length. So this should be stack allocation unless it's large, in which case we'll just use heap allocation. So we want to read equals into base stream.read into the memory. And then we want to read backwards. So buffer at I equals memory at read minus I, which should read that reversed, and it should be more efficient than allocating memory unless you are reading a very large chunk. So now I want to do read bytes backwards, which will be this content. Wait, read to big endian is always read forwards. It's just read bytes. Okay. Might be able to do that as well. Okay. So we don't want to change the interface of read. We want read to always read it forwards. We don't need to do this then. Um, okay. This will probably have to be as it is. Decimals aren't supported. All right. Oh, this isn't 16. I mean, they're the same size, but just for completion and accuracy's sake. String isn't supported. Oh, pretty sure that this doesn't work. Okay. Mm. Wouldn't that be nice? Okay. Mm. See, because we also can't do write internal buffer. Or we could do write internal buffer dot slice or dot as span slice 0 to 2 or 0 to size of character. We'll deal with that in a second. Actually, what I could do is write value dot as span, write forwards. I mean, the characters are always written forwards. Shit. Writing the bytes forwards is actually incorrect. So I now have to determine, do I want to make it ASCII, which would be simple and I can just write it forwards, or UTF-8, which I have to reverse the bytes. You know what? No, I can't just ignore it. For now, throw new not implemented exception. We'll deal with it later. Assigned byte internal buffer at 0 equals value. Right. Internal buffer dot slice or as span dot slice 0 1. All right, we at least have something. Now we can make a test project. Okay. All right. This should work very simply. We'll do a quick sanity check. Apparently, it's going to run all of the core OSC tests too, so that's going to take a while. Hmm. Okay. Stack Overflow. How? Hmm. Maybe we can get rid of some of these. I mean, a lot of these are overridden because in a previous version of this class, it used to have a captive binary writer that it would do all of the stuff to. And then I got rid of that and made it direct. And then now I'm making it a derived class of binary writer. So it's getting more and more complicated. But we have successfully written a 77. Okay, so for writing a byte array, we expect that. What is its default behavior? We write the entire array backwards? Do we write it forwards always? I guess what does the base binary writer do? Okay, so byte array should be okay. Byte array should be written forwards and never reversed. And it is not. We didn't get any information. Okay, so this just doesn't work. We'll do is true. The test array sequence equals test array 2. So it did actually work. It's just that it isn't capable of doing the thing. We're gonna have a quick test write empty byte array. So if I write nothing, this should be true as well. It shouldn't throw any exceptions. Then we'll do test write byte span. Empty byte span. We do expect that they will be written forwards. Oh, I'm only running one test. Oopsies. Okay. Still fails. Ah, this should be -1. Okay, so it is being written backwards. Um, Now comes the hard part. Do we want spans to be written backwards or reversibly, and byte arrays to be written always forwards? Because writing span is the main way that I do the writing. I'm not sure how I want to handle this. I mean, you could just do write forwards. So for this example, I could do write forwards. I write bytes forwards, which does make this test succeed. I'm just not sure what I want the default to be. I mean, it is a big endian writer. The thing that's questionable then is, do I reverse byte arrays? And I'm not sure. I think I do. Then comes the hard part of doing tests. No, it should work on big endian systems too, actually. The output should always be big endian, unless you're specifying forward writing things. So we would expect that the output of this is actually dot reverse. So the input is treated as a little endian. We will do a test initialize. I mean, we don't know what will happen if you're on a big endian system. Actually, if you're on a big endian system, this would be written forwards, but I'm not going to put it in every single test. A conclusion. Actually, I probably could. No, because this is just, you know what? We're just not going to test it for big endian systems. Nobody uses big endian anyway. Test write int 32. Neither succeeded. So actually, they should appear as we write them. We write them in big endian. Actually, we've already done byte. And we could do S byte really quick. We would expect the sequence to be the same byte we put in. We want one for int 64, of course. Do the same thing for the unsigned types. This test is already defined. Nothing should really change. Okay. Now I'm going to need to go figure out what these are. The flow should be 41 F0 0 0 0 0. We'll quickly test that. Okay. A strange amount of things have failed. Hmm? Oh, that's why they're failing. I may or may not have forgotten to remove a few things. A bit of the pizzazz, if you will. Int 64 isn't working. That's weird. course, the double will be wrong because we don't know its thing. Okay. Double is hex 40, hex 3E, and then a lot of hex 0. Okay, now we just have the problem that writing the byte array is not working. Okay, that should fix it. I wonder if the OSC tests work. I haven't tried these in a while. I think there's a couple that are like throughput tests. Can't even run the tests. Oh. I don't have the right I don't have the right shit installed. We're just gonna update this to .NET 10, that's fine. I don't have .NET 9 installed. I think there's a couple throughput tests, which are gonna take a while. Thinking. Okay, they all passed. Yeah. I mean, what? Didn't mean to do that. This will be interesting. I'm curious to see if this is going to change how it handles. Holy shit, it's twice as fast. Holy shit. Because this is one of the things that's been kind of problematic, is that the big endian binary reader that I wrote is kind of slow, and this next one is way faster. Because of its aggressive use of spans. Problem is, I think nearly everything uses big endian source binary reader and big endian destination binary writer. So I'd have to do like a find and replace on the entire solution to get rid of those, or at least on the entire project. But I could do it. We know that the reader at least works. But I want to quickly make some tests for the writer. This is the writer. So now we need to make one for the reader. Okay, most of these are going to fail. Annoyingly, they're going to fail to compile. We're just gonna make these not exist for the time being. Actually, all of the defined ones didn't work. Mhm. Okay, that seems to work. Okay, now comes the hard part where everything breaks. I might just update this to .NET 10. We'll come back to this. I know that that's going to be a pain in the ass. Good morning. How you doing? I'm doing all right. Got the day off? Nice. Speaking of, actually, I need to 1 second. I'll be right back. Okay, sorry about that. I'll drop my key off. I always roll over these earbuds. I'm surprised they still work. How much I've run over them. Okay. So we're almost done. Um We'll need to fix this. But first, we have more issues with... Here, let me hide this project. That is true. This test will have to be deleted. It no longer works. Oh, nice. Congratulations on your 7 watch streak. Big Endian binary reader. Coding.utf8. Okay. Now we just have to deal with all of these blowing up. I have been reset. I don't think these are used. Performance critical OSC message converter. I don't think we use it. It's defined here. I don't think it's used. Here's what we'll try. We're just gonna do that and see what happens. If it blows up, it will have blown up. There's got to be a better way to do this. Actually, can I do dwords dot write final dot to string? Honestly, we could just do this. Dwords dot write value. That should be a little faster. Now the problem is there's no overload for read that is guaranteed to read forwards. So this is where we need... Oh, no, there is. Read bytes forwards. Oh, it's inaccessible due to its protection level. Let's make it public. Ooh. Should be able to rebuild now. Not quite. Why did this not get updated? Honestly, just do new. Brother. I already fixed this. Okay. We are now migrated over to the new version of Big Reader. Also the only version of Big Reader. Now the question is Core OSC going to work? We have a couple no's. Ultimately not the worst. Serializing 5 bytes isn't working. Right. Hmm. Let's see if this fixes the problems here. I don't think it will fix all of them, but OSC is not Unicode. Most of it works. We just need a couple more things. Now the only difference is that both of these fail. Mm. This is either going to work beautifully or break all of the bytes interface. Stack Alec things are not guaranteed to have no content. They're not cleared for you. Okay. All right. Now we get down to the fun part, where we have to validate that this still works. And it probably doesn't. First, in the interest of having all of the data, I am going to take the original data for VMC, and I am going to bring it into this directory. And we're going to compress it. More importantly, we're going to time how long it takes. Okay. Scary display capture. Here is my command. We're going to go ahead. It's going to include both the pre-pass and the post-pass. This is going to take a long time because the file is 37 gigabytes. I expect this to take like 2 or 3 minutes. So I'm going to go get some water. Okay. It is the second of those splits. It took 66.33 seconds to do the pre-pass. Now we do have to keep in mind that this input file is massive. It is 37 gigabytes. So, going to take a while. 3 minutes may have been slightly optimistic. Might take more like 4. I don't think we'll get up to 5 though. Maybe we will get up to 5. We're not exactly moving quickly. One of the notable things is that we will have slightly faster OSC, just because the binary reader is so much faster. It's just 2.5 times faster, just from better usage of span and stuff. Why can I sign into a clock? Sorry, I've just noticed that. Why the fuck can I sign into my clock? Okay. So it took nearly 4 minutes. So let's write this down in our document here. Okay. So now what I want to do is the same thing, but SNR2 VMC compress, which will use the system SNR2 installation. Which should be a little bit better. It's a little bit newer. I don't think it's going to be like 40% faster, but in the interest of being as accurate as possible, I do want to give it a shot. We're going to save a lot of time in the pre-pass because that's very limited by the binary reader performance. So a little curious as to what the memory looks like. Snow 2 is using 200 megabytes of memory. Not exactly small, but not exactly the craziest thing either. Okay. Nearly exactly the same performance. Halfway there. Looks like it's going to be nearly exactly the same. Getting there. I know this is taking a long time, but it is important to know where we came from. Nearly exactly 5 minutes. Once again. Okay, that is 237.47 seconds. Which is nearly the exact same number. It's only off by 350 milliseconds. That's probably by me just not clicking it in time. So, the question now is, how do we perform on new SNR VMC data? So we have to put in a new command. Need to get the name of the SNRC file. Okay, so we're going to do VMC compress origin.snrc. The output file will equal okay. Oh, I have to pull the plugins. Right. So it doesn't write at all. Because this happens. Yeah, the headers change size. Yep. So if I pull this, it's happening immediately. Oh, I have a ulimit set. That's why. All right. Really quickly, I want to see how the performance goes for the prepass. Oh, well, that's annoying. Boost. It'll be about 1 second too long. Then it crashes. Chat, I didn't think it was going to write. We're just going to see what happens. It should actually be pretty substantially faster. But we will see. It doesn't feel any faster. I'm going to cancel this. This isn't a significant change. Okay. So the problem we need to do now is we need to take this OSC compressor, VMC compressor, and get rid of as many allocations as possible. A lot of stuff that's been removed here. Hmm. Oh my god, there's so many things. Okay. So the VMC compressor must compress from a stream, and I think it does. Actually, how does it compress from a stream? Because IFMC compressor could probably do slightly faster with a stream. We override compress packet. Ah. Hmm. Chat, this is some atrocious code. Let's see. This is probably going to be a pretty thorough rewrite, isn't it? So this array fill for the character buffer should probably happen when we're reading a string and not at the top of the thing, considering it is never read outside of that function anyway. So we're going to do it in this string. So this isn't being run because we don't have to remove duplicate messages unless it's on by default. It could be on by default. It's not on by default. Okay. This is not on by default. We don't need to worry about it. Do we even use OSC anymore? That's probably why the speed didn't go up at all. We're not even using Core OSC. We're only using it for this. That is it. That is the only thing we're using it for. So that's why improving Core OSC didn't actually fix anything. Now we do use it here. Do we? We do. We use an OSC message converter. Or do we? If I delete this. At this point, we could probably remove Core OSC from the source tree entirely. Because we're not using it. We're using it for one thing, and that's to deserialize strings. That is it. Which I think is crazy. Are we not even using them for, like, writing arguments? I might have to let one go and just see if it even creates a valid file. For that garbage collection. This garbage collection. It's like every millisecond. I like that if you look up at the diagnostic tools, it's having trouble keeping time. It has been way more than 2 minutes. So this is going. I can check my VGen. Did it crash? Nope, it's just really struggling for those last ones. So it did crash at the end. Kind of hoping it would tell me where they were different. That's not good. Hold on. X delta 3 encode from snr2dev.origin.snrc to snr2.origin.cf.vmc.snrc x delta.xd3. All right, I'm gonna see by creating an X delta how different they are. Because WinMerge will not open files these large. I think WinMerge is 32-bit. That, and it probably wouldn't survive trying to compare files this large. Okay, so the X delta was 20 megabytes, which tells me that these files are pretty similar. Although the actual size difference is only 2 kilobytes. The thing that I don't understand is how is the header changing size? The SNRC or the VMC header doesn't change in size. We don't change it. The only thing we change is this. But these values should always be the same. I would be very curious to see where most of the time is going in this. Because in terms of input output, we have that basically covered. But yet still, we're losing a ton of time. Probably a decent amount of time is spent in garbage collection. It is struggling. I think I'm running out of like memory, because the more debugging you do, the more information it compiles, and it doesn't properly clear them. We may try for that. Hold on. I'm just quickly running disk cleanup. All right. Give it a second shot here. Okay. Now that we've cleaned out all of the debugging information, it should be a little bit faster. Look at how much faster it is. I'm going to let it run for the equivalent of 3 hours. And now I want to know, what is it spending all of its time doing? Allocation rate is 1.45 gigabytes per second. GC has run about 160 times. This makes sense because all of these are being basically, the prepass is it gets a packet, it queues it, and then that lives in memory until it is fully processed. And the limit for the queue size is 12,000. So a decent amount of things are live at any given time. It is weird that it has literally no information. Struggling really hard trying to get it. Wild. Okay. I have now deleted nearly everything in the temp directory, which is where it stores all of its diagnostic data. I've also absolutely blasted all of the background tasks that were running. I'm gonna let it run for 3 hours. Okay, now I want to know, what is the CPU doing? Okay. It's reading strings. Okay. Hmm. You can't use references like that. Hmm. This might work. This might work. I have no fucking clue. It's either going to be fast as shit or absolutely atrocious, and I have not a clue. We're going to do what anybody would do and test it on release. Okay. Probably shouldn't have tested it on release. It's fast as hell, but doesn't work. For testing, I'm going to make it single-threaded. It makes stepping through it easier. Why am I going through 4 threads? Why is worker threads of 4? And it should be of 0, or 1 rather. Bruh. Just creating a billion threads that are not being used. It's reading trash into the buffer. Why not? Is the data at this pointer actually just null, or? Wait, what? It's because this is the wrong buffer, that's why. It didn't start the clock. Actually, hold on. It's not accurate because it's got the debugger attached. Oh my fuck. This clock is the worst. Okay. Only took 20 years. Okay, so it finished in 22 seconds, but it didn't get the content. So it actually didn't work at all. Back to the drawing board. It's just reading the same value over and over again. something wrong here. I don't know why this is not working. I don't know why it's not working. we even call read types? Nope. See if this helps. Might be about where the values are. I do notice it's not writing anything about the pre-pass progress anymore. Oh, because it's single-threaded. Okay. Let's pause this. How we doing? Okay. We've got some decent values now. So let's come back over here and restore the fact that it used to be multi-threaded. And run it. Still no reports. Oh? Okay, it's reporting very slowly because it actually is just so much slower. It is wacky slow. And I'm not quite sure why. Where is it spending all of its time? It probably would be a lot faster if I read more than one character at a time, wouldn't it? Okay. Let's see if this does any better. This should be far more performant. Instead of reading 1 byte at a time, we're now reading several at a time. Yeah, and that single-handedly has raised the speed by probably 75%. Or actually not 75. It's probably around 3 times faster. And yet there's another problem. Okay. So, problem now is that it's not actually reading the strings. It says it is. But for whatever reason, as far as the bags are concerned, there is nothing in them. You can kind of tell too. If the memory usage stays really low, that means that it's not actually finding any values. So my guess is that byte count of internal buffer is returning 0 because it's an empty thing. Okay. It is returning the right byte count. I think that's why. So it's gonna be good. I can tell because the memory usage is high, which is what we want to see. High memory usage means there's actually content in the bags. Okay. Once more, we're going to attempt the clock. I do not have the clock open. I'm gonna say mean things. Alright, I waited for it to be done. Yeah, I'd be curious to see what the rest of the time is being spent doing. I could maybe speed it up a little bit by reading more than 4 bytes at once. Or reading more than 4 characters at once. Looks like we're gonna get 60 seconds again. It's actually not faster at all. Okay, that's a lie. It's 5 seconds faster. The first order of business, the first thing I want to try is go back to reading 16 characters at a time. Wow. That should have been faster, though. Why not? Out of curiosity, if I set it to 1, how does it perform? This should be atrociously slow, by my estimation. And it is. Okay, what if I read 12 at a time? Is it really that slow? Wait, I don't even think it's finishing. It says it has a ton of CPU usage, but I'm not even seeing any movement. So it gets stuck into an infinite loop at 12. Hmm. The only way I could think to raise the preprocessing speed is just to spin up more threads. Like 12 threads. I mean, it is a lot faster. Uses a lot more of the CPU, but it'll be done a lot faster. And then you get to the slow ass process. Okay. Let's try to get this process to be a little faster. I think that this read string operation is probably where we're losing a lot of time. Let's see. Where are we losing all of our time? All right, then we have the portion where it's just single threaded because we can't write to streams multi-threaded. The question is, why is it so slow? Hmm. Hmm. I did specify little endian. Hmm. Hold on. I had to run it without the debugger attached. It'll be slightly faster this way. Yeah, it's still not fast. Let's see. The major problem is we could make it really fast if we could multi-thread it, but we can't because it writes to a stream. It reads from a stream. The The other problem is we have intra-frame compression. Because we have removed duplicates, which causes intra-framed compression. So that is a problem too. I just don't know where it's spending all of its time. I wish I could just skip the pre-pass, but I can't. Should have checked the pre-pass timing. Should have checked those times. We really do need to get it as fast as possible. "62 seconds were spent in this, which is impressive considering 62 seconds have not yet elapsed." Let's see. Using a lot of self-CPU. This is taking a long time. Hmm. Well, we can inline this. So at least we're not slicing it twice. It is a little faster. We could attempt this and not use the internal span and instead use something that's on the stack. And just always stack Alec. That might be significantly faster because we're not doing any heap access. So it should all be in cache too. Try it. It seems about the same. Mm-hmm. I don't understand how it spends so much time in itself. What is all of this time? See, what I don't understand is that 75% of the time is spent not doing anything. Why is so much of the time spent doing nothing? Alright, with this design, we're using the same stack alloc things. We're not reallocating things on the stack. Which should maybe be a little bit better. Hopefully. Yeah, it's about the same. Damn. What more do I need to do? Pick one? It's just flip between them. Oh my fuck. Okay. No, I don't need to see my debug information. That's fine. No, I don't need it. Oh my fuck. Visual Studio, how are you this bad? It is actually freaking the fuck out. We have to go kill all the temp. I love having to kill all of the cached shit. Love that this is something I have to do periodically. If I'm lucky, I'll be able to see the actual data. Giant font, okay. Self CPU of 84 seconds. I don't understand why, though. Mm. Here's what I'm gonna try. I'm gonna try running it on release, which I just realized I may or may not have been updating all of the plugins for, and those might be like super old plugins I was using on debug. Um, it is about 50% faster, and it didn't immediately crash, which means that there is content in the bags. But then again, that's with more threads than we're used to. Hold on. For an apples to apples comparison, we need to be using 4 threads. No, it's exactly the same. How is this like the fastest it can go? So I don't understand. Is there no faster way to read ASCII characters in C#? It could do all the comparisons with bytes instead of strings. It spans. It actually might be the best idea to just read bytes directly, because we know that they're ASCII. Um, because I mean I've been fucking about with this for nearly like 4 or 5 hours now. I have not made any headway. It's still just as slow as when I started. I feel like the pre-pass should be so much faster though. I can't seem to figure out why it's not possible to read anything more quickly. Hmm. I'm honestly so confused as to what to do. I mean, I could write some sort of application that does it in C++ and then use that, which should be a little bit faster maybe. 'Cause literally all I'm trying to do is fill these lists. Once I have those lists, it's Jover. Like, that's all I need for the pre-pass. Damn. We might just have to write it in one pass and take the performance hit of writing 2 files. Because it would allow it to be so much faster because we could get straight into the post pass. There's so many files open. Hmm. Is this being caught here? I almost wonder if it would be better as a single-threaded app. I mean, that problem there is that we don't know that the base stream is a memory stream. Hmm. Actually, hold on. So we have a memory stream containing the entire file. We could just directly read it. What the hell are we doing? We have the memory stream. We have the packet data as an array. What am I doing? Move it down here. This is potentially the fastest we can get it to be. If this is slow, then I legitimately have no ideas. Okay, so it didn't like that. It might throw an exception if it reads at the end of the source. Okay. The data index is 0. MS position is 0. Read 4 bytes. Buffer index increases. What? Three, 4. Oh. Okay. We know we don't um advance the base stream's position at all. We're gonna try building it and doing it in release, despite the fact it's incredibly slow. Okay. Um, we can't do a rate copy because it's not the right type. Shit, man. Go to bed. No. Not when there's performance to be gained. I'm struggling over here. Everything I seem to do is just slower. Everything is so slow. I thought for sure this would be fast. The only thing that might make it work is if I get rid of this try catch. If it has to do, like enter some monitor or something, we'd be doing that several million times per second. No, it's still slow. Damn. No, that's not going to do it either. Can't you replace the for loop with a Marshall copy or something like that? No. The problem is character is 2 bytes wide, which is why I can't do simple copies. If I could just do simple copies, it would be so nice. I mean, I could probably hold on. um So what I might do is unsafe pin it and just directly copy the memory byte, copying to every other byte. There should be no bounds checking here. And this should be ideally as fast as it could possibly be. If this isn't it, then something else is the problem. Holy shit, that was it. Check out this crazy fucking speed. Check this out. Look at how much faster this is. So literally an unsafe memory copy is the only way to get this to go quickly. It isn't reading things correctly. We're in overtime. From the top. Yeah, okay. So, oh, C sharp is my computer's little endian. That's why. Yeah. This only works on little endian computers. This is the most bung solution. I'm sure it'll work. Oh god. It's throwing key not found exception still. Hold on a minute. Is this not correct? Not C is the quote character buffer. Hashtag UNDLE. Right. We got our bundle. We write one null character, ideally. Yeah. Red is read size. We check through the buffer. We do actually have to step through this one by one. So path is bundle. So now we read our string. We'll just skip to when this returns. Path is now bone po. So that's not good. It's not supposed to be bone po. All right. VMC X. 5, 6, 7, 8. Huh? Oh. It is unfortunately a lot faster when it doesn't work. Wouldn't it be nice if it was super fast and worked? It's still throwing exceptions constantly. Buffer index is increased. What is the problem? bundle. VMC X bone. Dumb. 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 How in the fuck? Oh. Didn't happen. No proof. No balls. Oh my god, it's so much slower. What the hell? All I did was add one factor. Because I don't think that size of character is being evaluated at runtime. I'd be pretty flabbergasted if it was. Oh my god, it's so much slower. Okay. So, the unfortunate bit is that means that this isn't even the slow part. It's somewhere else. Which is crazy because I've unimplemented like 39 billion instructions. And this is still somehow going to be slow. It could be like unpinning these maybe. I have no idea. We're about to find out. Through the power of debugging. Hey look, the debugging is actually working semi-well for once. I've had to restart and delete the cache for Visual Studio twice. Maybe 3 times. Let's see. Where is my time going? Because there isn't a whole lot going on. Oh. Nope. 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 Dumbass forgets it's single threaded. Where? There. Dumbass forgets. Oh, gosh. Right. Let's see. So the pre-pass was a little fast. But there is a thing I can do to see how fast, which is whipping out the fucking stopwatch. Here we go. It didn't start. Windows stopwatch, how are you this bad? Okay. Our time to beat is 66.5 seconds. Oh, it already finished. No, it didn't. About to. Okay. So 45 seconds. It is 25% faster. We saved 25%. It only took us 6 hours. I've been on this grind for a while. And we still have to get through this, which is still so slow and very single-threaded. But, yeah, I don't know how this is so slow. You would expect it to be pretty fast on account of it doing fuck all. But somehow, it's just really slow. I'm going to do some of this. I'm going to check the diagnostic tool, see if it gives me any information that's useful. It's probably not going to, but we'll hope that I can actually read the diagnostic information this time. I kept flipping between the flame graph and the collar graph. I'm like, I do need to see this. All right. It is self CPU of 22 seconds. I could actually, now that we're doing this, I could exit this immediately. That is a decent point, because this loop is also kind of slow, because it does bounds checking. So what I can do is do all of that at once. Red is the number of words read minus I plus 1 is the amount of space not read. We could just do this. What am I doing? Who needs this max I shit? Just declare I outside of the loop. Okay. We now have the number of bytes read. So int advancements equals I plus 4 minus I over, or mod 4. We don't actually care about this value. Buffer index plus equals I think. Comment this. Comment all of this. This will always be, hold on. Actually, I don't think this matters. We can just always do this line. This is either going to give us atrociously incorrect values, or it's going to be really fast. And I have no fucking clue. We'll just let it go and see how many errors we get. None, but it doesn't seem that much faster. The other thing I could think to do is place the while loop inside of these fixed sections. Hold on. Where is this matched? Okay, so it actually is matched if I do this. And the idea is, hold on, I haven't done that right. The idea is that we're not pinning and unpinning the data so much. So we're gonna try this on release again. It's going, I guess. How much memory is it using? Because that's a good indication of if it's working or not. SNR2 is not using very much data, so it's probably going to fail after this after the prepass. Usually what that means is that it's not actually getting any values. It's not reading things correctly. And I can't see if it's throwing exceptions. No, it survived. It is reading correctly. It's just somehow we can't get any faster than this. Even though I'm literally reading things directly. Huh. It feels like it should be faster. But I can't think of any way to make it faster. It's all in an unsafe block, which is probably going to blow up at some point. It also does blow up. It's guaranteed to blow up if you read a string at the end of the data. It'll just read past it. I'm not doing any protection against that. I mean, I don't think that there's any more optimization to be done here. This is as fast as it can get. I think. The only thing I could do is get rid of this thing which isn't being used. Oh. No, because it advances by buffer index. Yeah, so this advancement variable is actually unnecessary. It's never read anyway. All right. We're going to do our final speed test. That's not the right one. There it is. I will say if there's any process that requires extreme optimization, it is probably VMC recorder or the VMC processor. Holy shit, we saved 50% of the time. There. 31 seconds ish. See, that's an improvement from 66 seconds. I can live with a 50% reduction in pre-pass time. And we can actually reduce it more by just... Chat, it's so much faster now. It actually doesn't seem to be going that much quickly. That quick. We might have hit the final barrier of this this entire system. There is one insurmountable barrier to going faster. And it is kind of difficult to get past. And we might have hit it. That barrier is that the input file can only be read so quickly. And it looks like round about 25 seconds is as fast as I can get it to go with my current setup. The only thing I could do to make it faster at this point is make it read the packets faster. And from what I know, it's pretty quick. It's pretty rapid. So I don't think that that'll happen. But we would have to make this faster. And this is just called in a simple loop. I mean, I could read it. Huh? I could just make a binary reader. Wait, maybe I can read this faster. Yeah, I don't think we're getting past this. Cinema. I'm curious to see if this will work. It should catastrophically fail immediately. Well, it catastrophically failed immediately. Oh, -4. That is doing heavy lifting. Yeah, I don't think it did that much. But yes. Trying to think of if I mean I could. No, I don't think it'll do anything if I raise the buffer sizes for the files. But I don't. I think that we're limited by how much data we can take in from the disk because we're reading like 1.2 gigabytes a second, which is, I mean, no small amount of data. You haven't noticed yet. The input file is 36 gigabytes. I'm trying to pinch every second out of. It is an astronomically large input file. What are the typical input sizes? Luckily for me, I have the StreamPods auto folder right here. 15 is like the highest sensible amount. Sometimes we go higher, but like 15 is a pretty high amount. And I'm trying to do one that's 36. And I want it to be as fast as possible. All right. I would love to get into the main files content, but I have been streaming for like 10 hours. It's been a few hours. So I should probably head out. I do have a place to be in less than an hour. I mean, I would say it's not that important, but I've been trying to get a hold of this guy for like 4 days, so I'm gonna take it. Also, somebody replied to me on VGen. Need to take a look at that really quick before I go. I have been absolutely fibbed upon. He did not reply. Absolutely lied to. Deceived. I will never forgive you. Gmail, I guess. Let's see. Sorry to pop out as soon as you came in, but that's been 10 hours. We're going to raid Funny Bunny again. Funny Bunny. Oh, they're in a be right back screen. And I'm getting an ad for Fortnite. I just realized, what the fuck? Where's 24 minutes? Do I raid them if they're not present? Do we look for someone else? We could raid Bert again. He would never expect it. We'll raid him with exactly the same message we did last time. This is our raid message. If you're not a subscriber, that's perfectly fine. It's just everything except for the emote. Everybody, thank you for watching. I hope you enjoyed and enjoyed watching my pain. Look, I've said it before and I'll say it again. Programming is one of the most masochistic endeavors you can go in on. Um, when it works, it's absolute euphoria, and when it doesn't, it's like shit. So, everybody, thank you again, and I will see you next time. I still feel like Markiplier when I say that. But I will see you next time. Bye. I have a stream ending soon screen. I should probably use that at some point, huh? Check this out. Did it work? I don't actually have a way to tell. Where is my window? Ah, it does work. See that? That right there. It's certainly one of the things of all time. See ya.